Alright, earlier we did a mole to mass problem where we were given a mole value and asked to find a gram value. Well, as you can see from this problem, now we have it reversed. It says how many moles of sulfur trioxide gas are produced from 13.6 grams of sulfur burning an oxygen gas. It's the same number of steps. We're still going to have 3 brackets in our setup, but it's in reverse. So we're given mass in this case. We're asked to find moles, which means we're still going to need our periodic table because we're going to need a molar mass. But we're going to use it at the beginning of the problem instead of the end. So how am I going to set up this? Well, we're going to take our setup, our traditional setup for any stoichiometry problem, and we're going to basically say, alright, what am I trying to find? I'm trying to find moles of SO3. And what am I given? I'm given 13.6 grams of sulfur. So if I set up my standard bracket system, the first thing I need to remember is that I cannot go from grams of one thing to grams of another. The only way to go from one substance to another is using the mole ratio. And I know from the reaction that for every 2 moles of sulfur, I'm going to get 2 moles of SO3. And this is convenient because this means we have a 1-to-1 ratio. So if it's 1-to-1 ratio, that's going to make my conversion a whole lot easier. 2 to 2 is the same thing as 1 to 1. But I don't have moles of sulfur, I have grams of sulfur. So I'm going to have to take my grams of sulfur and I'm going to have to convert them to moles of sulfur. Well, I know that 1 mole of sulfur I can look up on the periodic table and determine its gram value. And when I look on the periodic table at the molar mass of sulfur, I see that it's 32.07 grams. So if I just stopped here and divided 13.6 by 32.07, then I'm going to give me moles of sulfur. Of course, I don't want moles of sulfur. I want moles of SO3, which means I'm going to have to go one more bracket. Moles of sulfur here. And what am I trying to find? I'm trying to find moles of SO3. And then I think to myself, where can I find a mole-to-mole ratio? You always look at the balanced equation to find your mole-to-mole ratio. And as we said earlier, it's 2 to 2. So I'm going to put a 2 there because of that 2 there. I'm going to put 2 next to moles of sulfur because of that 2 there. Now again, I could write 1 to 1 and be okay with it. But just for teaching purposes, I'm going to leave it as 2's. But if you wanted to just put 1 over 1, you'd be fine if you wanted to do that. My grams cancel. My moles of sulfur cancel. And what am I left with? Moles of sulfur trioxide. What am I trying to find? Moles of sulfur trioxide. So in a sense, I can say to this bracket, forget you. I just need the moles of SO3 at the end. And what does that leave me with? Well, it leaves me with 13.6 divided by 32.07. And when I divide 13.6 by 32.07, and I'm going to round this to 3 sig figs, because there's 3 in the given amount, 4 here, everything else is infinite sig figs. I'm going to round it to 3, and I get 0.424 moles. So in a sense what that means is if I wanted to find how many moles of sulfur trioxide produced from this given amount of grams, I'm going to get 0.424 moles of sulfur trioxide. And that is your standard grams or mass to mole stoichiometry problem.